Alright, CNT140, we're looking at Chapter 9 on fiber optic network design. There's a bunch of different objectives we're going to tackle in this chapter. This being a really large chapter, we're going to focus on kind of the high points in here because there is so much information to kind of get through, but there's a lot of things we've covered before. So we're going to stick to a lot of the high points on this chapter. Alright, fiber optic network design. It's really a process leading to a successful fiber optic connection, whether it be a network or connection between sites, if you will. Requires interfacing a lot of other networks, LANs on each end, if you will, possibly even other connections, other types of networks along the way. So there's a lot of pieces to consider. You have to consider any permits or easements or permissions and inspections that might need to happen along the way, especially as we're moving outside of our building. This might actually you might actually have component selection that you're dealing with, where we're going to place the fiber, how we're going to install it, whether we're going to bury it, aerial hang it, etc. Testing and I shouldn't say certifying, but testing for function of the link, troubleshooting, and any sort of documentation at the end for this. And actually, documentation planning needs to start and include all of these things, and then as you're actually doing the install and finishing the install, documentation, testing and documentation need to occur along the way as well. The design really needs to be completed initially, so you have a good estimate. The estimate will include all the components involved, all the potential obstacles in the way, things that you might need to rent, permits you might need along the way. All those things need to be considered before you actually start the project. Similar to the bid spec we're doing, we try to think of everything and get it down on paper before we actually do it, and getting us a good estimate of what materials do we need, how long is it going to take before we even start ordering the materials. The designer needs to understand pretty much all of these processes. So it's usually somebody that has had experience maybe doing the installs over the years that works their way into the designer role. There is actually certifications for this. Fiber Optic Network Designer, Fiber Optic Association has one, Fiber Optic Network Design. And again, this is somebody that usually has been there, done that, and worked their way into the role of like, I kind of understand all the pieces, now I can actually plan it out. And they're showing you here, a campus, literally the fiber optic links that would be connecting maybe the buildings on a college campus, if you will. One of the things you're doing is working with a lot of other people. There's a lot of people that will be interfacing this network, so there's a lot of people that would potentially have input or needs for this network. So they roll down through a list of all kinds of people, including contractors that you might be bringing in to do certain parts of this project. So communication between all those is key. The designer, the network designer as well, your fiber optic network designer, really needs to understand all the cabling and equipment that you're using, the technology of communications, how these things are functioning, and keeping up to date with practices or even maybe changes in laws and regulations that come along that might affect how things are done. Designers need in-depth knowledge of the cabling, the equipment and so forth, standards, codes, that sort of thing. They should be familiar with telecom equipment, site surveys, as we said, local codes, and standards that might be in an area that you have to adhere to. They should be familiar with electrical power, including, UPS systems at the locations, and familiar with estimating. Because there's skills in estimating and knowing how long it's going to take or about how much labor is going to be involved to get a pretty accurate estimate for the customer. The designer should have a background of fiber optics, so we're kind of reminding you of the Fiber Optic Association Certified Fiber Optic Technician, somebody that maybe has done that for a while, and then also needs to know, as we sit here, product standards, codes, outside plant design, and so forth. Experience with CAD systems is a definite bonus. Computer-aided drafting systems, being able to draw out plans or read blueprints and so forth, as well as draw out plans for what's going to happen. You need to establish where the work is going to be built and what communication signals that it will carry. That is going to kind of drive what is needed. Kind of like if I'm going to design a road, I need to know what kind of traffic is going to drive on and how much to know how the road should be designed. Same kind of idea. They should be familiar with premise networks because you're probably interfacing them on each end. And that is going to when cabling enters and exits a building, that's going to determine the fiber and types of fiber that are going to be used. Outside plant or long distance have more stringent requirements that need to be considered as well. All those need to be factored in or thought of. Real design starts with your communication system requirements by the end user. What is it they need? What kind of bandwidth they need? What kind of distance is going to be covered? Again, maybe we're connecting two buildings, two site buildings to sites of a company. We're connecting them together, so we need to know what kind of distance, what is going to be carried across that, kind of what is your need now, what is your need down the road. And the communications equipment would determine the type of fiber, if necessary, and preferable what type we would need to accommodate their needs. Premise networks, this is where a lot of our focus has been all semester, is designed to carry LAN-based, Ethernet traffic, 10 meg to 10 gig, if you will. Typically, we have copper to the desktop, and we have fiber sections connecting maybe the closets or maybe connecting specific devices like access points and those sorts of things in our network. Data centers are going to have a combination of fiber and copper, but data centers, a lot of them are migrating to a lot of fiber, so they'll have a lot of fiber links connecting systems together. We might have security systems that are using copper and or fiber optic, cameras and entry systems and so forth. And our phone systems, your phone systems might be using the twisted pair for IP phone, out to the desktops and so forth. So that's where a lot of our focus is. There's a lot of copper, some fiber. Premise networks are usually short, less than 100 meters. So again, twisted pair can handle. You might need fiber optic links between your closets. So thinking back to what we talked about before and done, here's our horizontal cabling out to workstations. This is typically all copper. Connecting closets is fiber. That's typically our deal. Again, here's your horizontal cabling out to the work area, all copper. And then going between closets is typically fiber. That's what we have on premise networks. We might actually have some fiber to the desktop for some areas, so there might be some fiber runs out to a workstation where you do a media converter to be able to connect that copper, the workstation copper NIC, if you will, into the fiber network. Most of your premise networks are using multi-mode fiber, less expensive. The transmitters and so forth are a lot cheaper. So most of our links in a premise building are going to be multi-mode. There are some networks that are starting to incorporate single-mode fiber, hybrid cables to go between closets, kind of either thinking ahead or starting to install them for length needs, if you will. But there are places that are migrating to single-mode. Outside plant, we typically have for these long-distance links that are typically going to be your single-mode fiber. Longer networks, telecom, cable TV, utilities, securities, metropolitan area networks, that sort of thing, are all going to typically be longer links, so therefore single-mode fiber. Telephone networks, mainly outside, we're talking kilometers versus meters. Data rates 2.5 gig to 10 gig. High power lasers over single-mode fiber for distances. Even fiber to the home or fiber to the premise using single-mode fiber. Cable TV is, in many cases, kind of a hybrid system now. Run fiber out to a box neighborhood and potentially coax cable to houses to connect. And those hybrid fiber is typically going to be single mode to get out to your neighborhoods. Some of your highways and security systems would be using single mode fiber along them for cameras, sensors, that sort of thing. Some large buildings, airports, arenas, that sort of thing would be potentially using security cameras and those sorts of things around the building and using long single mode fiber links to get to them. Again, your premise is typically multi-mode fiber, but these links that we're talking about now and outside plant are typically going to be single mode fiber for the longer links. Again, metropolitan area networks, same kind of idea, longer links connecting buildings, typically going to be single mode fiber. Premise applications, copper, wireless, multi-mode fiber, some single mode, but outside plant, typically single mode fiber is your predominant choice. They remind us of the question of copper, fiber, wireless. Many networks, especially premise networks, are a combination of all three. Like we showed before, we would have, copper, let me say this again, fiber going from one closet to the next to connect the closets, and then from there, copper out to outlet boxes to connect workstations, copper out to access points, and then the access points are giving us wireless for the wireless devices. So even in a basic premise system, there's usually a combination of all three for the need. Some businesses, your high bandwidth users would have fiber out to the desktop. So there you would have fiber out to a media converter to copper link to the desktop computer. So a lot of combinations of that. Your premise networks is usually a combination of. Telco systems, copper to final connection to the home maybe, but a lot of times it's fiber the whole way, maybe even to the side of the house. Inside the house might be copper. Cable TV, same kind of thing. You might be fiber out to a box neighborhood and then copper into the house. But some are even running fiber up to the side of the house and just using coax inside the house. And a lot of those are single mode fiber to get out to houses. Internet backbones, predominantly single mode fiber, long links. Cities, again, single mode fiber connecting buildings. Cellular antennas usually have fiber connecting from the central office or the switching office, if you will, out to the antennas. Typically going to be single mode fiber out to them. And in remote areas where satellite might not be possible, or I should say remote areas where cabling might not be possible, there might be a satellite type connection, a wireless type connection, where there's not a cable infrastructure in place. So designing long distance or outside plant, a lot of things are based around single mode fiber. Some options might be more effective. They give an example of connecting across a highway or something. You might actually do a wireless link between them. Or if you have maybe two buildings in a city that you're connecting, you might use a wireless link between them, being a lot easier, a lot less permissions to put a fiber link in. Your choice of single mode might depend on these things here. How long? What kind of data rate do I need? Are we doing coarse or wavelength division multiplexing? That might drive the decision on the type of fiber that we'll be using. Our corporate networks, our premise networks, usually fiber optic backbone, typically multi-mode fiber, and then copper to the desktop and access points for your wireless users, like we mentioned before. Here's your copper out to the desktop. Here's fiber connecting the closets. And again here, fiber connecting the closets, copper out to the desktop. I might have a fiber run out to a high bandwidth user desktop. Fiber the desktop, if you will. Your premise networks, your building management systems might be using proprietary copper cabling. Some have migrated over to using your twisted pair. I think about a HVAC connection we set up for a facility where they just needed a data port into the network. So we just gave them a copper port next to it so they could get into the network for connectivity, browsing into and adjusting the HVAC system. But some still use proprietary copper. Some facilities are using fiber optic for security reasons or distance reasons. Security systems becoming more prevalent. Fiber has become a much more common choice because of distance. In addition, it's smaller and lightweight. A lot more fiber cables can fit through a conduit than copper cables. Cabling standards in the U.S., we're usually looking at your TIA standards to dictate how we should and should not be doing things. Internationally, we're usually looking at ICO or ITU. ITU is a subgroup of the United Nations. So when we're talking about international connection, we're usually following those types of rules and standards. Choosing the equipment. Again, this is kind of your next step once you kind of know what the fiber you need, what kind of equipment. And again, the customer knows the data. The designer installer will know the cabling and the equipment, and those kind of go together to determine what are needed, what kind of transmission equipment is needed for the fiber plant. And those kind of work together. Just like as we were doing fiber links in the room, we had certain SFPs we used to connect them. So a lot of those things are related to each other. Telecom has standardized on fiber for at least 30 years, so there's a lot of things that are already in place for your telecom systems to say, well, this is how we do this. This is how we do these connections. Again, shorter telecom links might use your 1310 nanometer on regular single mode fiber. The longer links might be specialized fiber using your 1550 nanometer wavelength for longer distances. All right, we'll come back in the next podcast and pick up where we left off.